Jai Hind everyone. Welcome to the class of Microwave and Radar Engineering. The subject code is KEC074 and the lecture number is 18. In the last lecture, we have discussed about the TWT, that is one of the microwave tube, and in the today's lecture we will discuss the another microwave tube, that is a magnetron oscillator. Now magnetron is all the tubes which we have discussed till now are the O types tubes. All the tubes which I have discussed so far are the O type tube, that is the klystron and TWT, as the magnetic field is usually what? Used for focusing the electron beam and is in the same direction as in the electric field. But this magnetron is of what? M type, because here the electric field and magnetic field both are perpendicular to each other. The magnetic field is perpendicular to the electric field, therefore it is known as the cross field or M type tube. The magnetron was first invented by the Hull in 1921 and it is further modified by the Render and Wood in 1939, and this magnetron is very useful in the Second World War. During the Second World War, that's clear. For the low power, we always prefer to have a microwave tube, that is a klystron, but for high power requirement we always prefer to have a magnetron, means the high power that is greater than 100 watt, and for the low power, it in the milliwatt, we always used to have a klystron for generating a microwave source. Clear? For higher efficiency and power, the electron beam can be made to interact with the RF field for larger duration. Exactly, that is in the TWT, because you have noticed that we always prefer to have a higher efficiency. For the higher efficiency, we need to have that electron energy should be efficiently transferred to the RF field. So interaction should be maximum, and the electron beam and the RF field interaction should be maximum to have a higher efficiency. And similarly for TWT and klystron also, we used to have a higher efficiency so that the electron beam and RF field interaction can be maximum. So similarly, this interaction should be also be maximum but in this magnetron, this interaction is in circular path. Therefore the difference is between the low slow wave structure in TWT and magnetron, that we have multiples of cavity in a circular path, reducing the size as well. Clear? Means interaction is maximum and the interaction is always in circular path in microwave tube, in magnetron, and this circular path, due to the circular path interaction, the size of the magnetron can also be reduced to a smaller. Now see this one. This magnetron is usually consists of circular anode with 8 cavities and with a coaxial cylindrical cathode, and this cathode is generally used to emit the electrons, and this anode with 8 cavities, they are used for what? They're used for the interaction between for creating an interaction between electron and the RF field. Now see this one. This is magnetron, and you will see in this magnetron, this center part is this center part is cathode, which emits the electrons, and this one is this one is anode. This whole area is of anode, that is a metal type conductor. And these are the cavities. Means first we have initially in the earlier side we have, if I say, now I'll just explain in the working, that these are the cavities. Clear? Now see, if I top view of this magnetron, is this one, that in between it is center, that is cathode, and this is the anode, and these are the cavities. In the cavity we have provided the we've got the RF output. Clear? Now see, input is provided to this one, that is V0. Clear? This is anode and this one is cathode. Clear? Now this is 8 cavity magnetron with DC magnetic field and the electric field. Now see, the electron coming out of the cathode have to move in a circular path between anode and cathode. Therefore, DC magnetic field is perpendicular to electric field, has to be there into the paper. Means if I say now see this one, that this is the electric field, this is the electric field, and this one plus sign means the magnetic field is goes into the paper or into the screen. So magnetic field is just like this one, goes like this, and electric field is like this. So they both are perpendicular to each other. Now see, what is the mechanism of oscillation? This is magnetron. In magnetron, the magnetron requires an external magnetic field with flux line parallel to the axis of the cathode. This field is provided with the permanent magnet or electromagnet. Wait a second. This field is provided with the permanent magnet or electromagnet. This DC field is normal to the DC electric field between the cathode and anode. Now see this one, if I say that this is only a cathode which emits the electrons, outside this, and this electron will continue to reach to this point. Now if I say this cathode is here and I have surrounded the cathode by a anode, now these electrons which is generated by the cathode will go to the what? Will go to the anode side, and this anode is providing what? Magnetic field, because this field is provided to the permanent magnet or electromagnet, and this DC magnetic field is normal to what? DC electric field between the cathode and anode. Now see this one is the straight path, means the cathode will emit and reaches to the anode side. Clear? Now see this one, if I apply a magnetic field, from by the magnetron and above the magnet and below the magnet, this field that the magnetron requires an external magnetic field, and this magnetic field is provided by permanent magnet, means the above is a permanent magnet and below is the permanent magnet. Then this field lines will get deflected back like this one, because means these electrons will have a circular path like this one to reaching from cathode to anode. Now see this one. Now this, not to have a sustained oscillations, we will provide what? Cavity in the anode. Now as we know that if I say for the LC oscillations, you know that if I say this is a metal and this metal is cut it out and electron is passing through this metal, when this electron is passing through metal, so here it will become what? positive, and here electrons will be emitted in the metal. Clear? So this is a whole metal, because as we know that the metal consists of electrons and protons. So when the electron is passing through this metal, the electron at the cavity side, here will be what? Positive will be accumulation. Positive means holes will be accumulated, and here electrons will be there. But if I provide a what? Inductor here, and this cavity is act as a what? Capacitor, then there will be LC oscillations. LC oscillations will be there, and on this LC oscillations, sometimes it will be what? Here it will be positive, and in other time, in another oscillation, here will be what? Negative, and here will be positive. Clear? And similarly, these oscillations will take place. Sometimes here holes will be accumulated, and here negative, and in LC oscillation, due to the frequency of oscillation, now when here most of the holes will be accumulated, and here will be negative, to provide the stability, the holes will and electron will what? Get attracted to this one, and holes will be created. So similarly, to provide a oscillations, we will what? We will provide a cavity across the anode, and earlier anode was like this one, this whole tube. But now we have provided a cavity in the anode. This one is cathode, and this one was what? Anode. Now see this, we have provided a cavity, means like this one, to get the oscillations. As we know that magnetic field is above the magnetron, permanent magnet, and so means magnetic field will be what? Into the screen or into the paper, and these electrons will get reaches to this one. So some here it will be at positive, and somewhere it will be negative. Similarly, in the another cavity, here what? Positive will be created, and here will be negative. Clear? In the next oscillations, what? In the next oscillation, here will be what? Negative, and here it becomes positive. When it becomes positive, and here will become what? Negative, and here it becomes positive. Is this one? This is the cavity. So these oscillations and this electric field is created due to the movement of what? Electrons. Clear? So electrons will what? Attract towards the positive, then it will, on the next oscillation, here it will become negative, the electrons will move towards it. So here a spokes will be formed, just like the wheel spokes. Now see this one. So because of the cross field between the cathode and anode, the electrons emitted from cathode are affected by the cross field, move in the curved path. If this DC magnetic field is strong enough, the electrons will not arrive into the anode but return to the cathode. Now see this one, that if I say, if I am providing a RF field, clear? If RF field is strong enough, now see this one. If there is no magnetic field, means there is no permanent magnet, the electron will be what? Drawn directly towards the node in accordance with the path A. Means this electron which is emitted by the cathode will reaches to what? Anode side. Clear? Now if I say, if magnetic field is there and this magnetic field is weaker, then this electron path which was going earlier straightwise, it will be what? Deflected and goes to the anode. So this path will be there. Clear? Now see this one, as we have cutted out the cavities, means some here positive oscillations and here will negative, here will be negative, here will be positive. Now see, due to the positive negative, the electric field will be like this one, positive to negative, and here what, positive to negative. Clear? And now see, when I am providing a magnetic field greater than the above, then what, the intensity of magnetic field, when the intensity of magnetic field is sufficiently great, the electron are turned towards the cathode without ever reaching to the anode with path C. Means when I'm providing a enough magnetic field, this electron path will not reach towards the anode, it will reach towards the this side. Clear? But it will also interact with what, RF field of electric field of this one, means this is the RF field. Clear? Now if I provide a much magnetic field is just way that it termed as cutoff field, then the magnetic field is just able to return the electron back to the cathode before reaching the anode, is termed as the cutoff field. Means the electron will be what, will be ultimately goes back into the emit from the cathode and arrive just into the cathode without ever reaching to the anode. This applied magnetic field is known as the magnitude of this magnetic field is known as the cutoff magnetic field. Clear? Now if I provide when this magnetic field, applied magnetic is exceeds the cutoff value, then the electron will immediately return back to the cathode. Clear? Now see this one. Here the electron what will interact with this field, and during this path only, or during this area D point, during this D point, the interaction between the RF field and electron will be maximum. Clear? So in the presence of anode DC radial field, in the presence of their number of fields, first is DC radial field will be there, magnetic rotational field will be there, centrifugal force will be there, and if the RF field and rotating field electron have the same frequency, if RF field means this one is the RF field. If RF field and electron field have a same frequency, the electron profile provides a mechanism forces to form a bunch and move in spikes. Now see how it will form a bunch. Clearly you will see that in the figure, that if I say when this electron emits from cathode, it will accelerate it in the accelerating field, but it will be now further accelerating in the further accelerating in this field. Now acceleration and deaccelerating field due to this field will create a bunch. Now see this one, how that this way on interaction on the bunching, this way it delivers a maximum energy to the RF field. Now see how the bunching forms. See this one, the signal with frequency suitable or close to the cyclotron frequency acquires more and more energy from C electron and get sustained. Now we know that the electron accelerated negative field retards in a positive electric field. Means you will see that this path C what will be retarded due to the negative electric field. This path C will be retarded, electron speed will be retarded due to the negative. Clear? Now it will on going further, it will what, this retarding field will be what? Accelerating. So accelerating and deaccelerating creates a bunch. Now see that the electron accelerates in a negative electric field and retards in a positive electric field. The electron, see, when it goes into the electric field of cavity 1, then it retards and transfer its energy to the RF field. Clear? Now by this time, this C electron reaches the cavity 2, the RF field of this cavity 2 gets reversed and this electron again retards further. Therefore, it transfers maximum energy to the RF field and finally merges with the anode. Clear? So therefore, the angular velocity of electron has to be in such a that it travels to form a cavity 1 to cavity 2. Clear? It means that the magnetic field is in such a way that this electron path, that it travels from cavity 1 and reaches to cavity 2, so that it forms a what? Acceleration, deaccelerating the accelerating the electric field, then deaccelerating the magnetic. It will create a bunching, and on bunching, on interaction with this RF field, it provides, electron will provide its energy towards this RF field. Clear? The number of C-type favorable electrons is much more than number of those in D and E electrons, unfavorable electrons. Because why they are path D and E are the unfavorable electrons? Because they do not interact with what? They do not interact with what? RF field of this one. So the favorable electrons will be what? Which provides the interaction with the RF field of what? Cavity 1 and provides the interaction of RF field of cavity 2. See, again you will see that the electron is further initially accelerating. Now see, on initial accelerating, now it interact with what? Negative side. Now it will deaccelerate it. Again the path will goes, and during this interaction, this electron energy will be transferred to the RF field. So electron following a C path, that is the favorable electrons, form a bunch and therefore form a spokes. The frequency of oscillation for electron path is in such a way that the centrifugal force and the magnetic force should have to be in equilibrium. Centrifugal force means this electron field, which forms a centrifugal path, and magnetic field, they should be in equilibrium condition, that is mv square by r equal to E into v multiply v naught. For the maximum power transfer to the RF field, the frequency sustained will be when frequency of oscillation is equal to 1 by f equal to 1 by t, that is equal to E upon E into v naught upon 2 pi m. Now, what is pi mode? Pi mode usually consists of what? 8 cavities, and in this, phase difference between the two adjacent cavity is what? Is pi, and it is known as the pi mode. When there are 8 cavities, means 8 into 5 will be equal to what? 2 into n pi, that is a total phase shift in the complete cycle has to be multiple of what? 2 pi, and this difference phi should be what? In higher mode, this difference should be what? Less than greater than the less than the pi. Clear? The pi mode oscillation is what? When phi v equal to 2 pi n divided by 8, when n is the number of cavities, 2 multiply pi into 8 divided by n equal to 360 degree. Clear? So that is known as the what? This one, if n equal to 0, then phi v equal to 0, and this is known as the 0 mode. Mode jumping and mode stepping is a technique which provides the method from which provides a stopping or preventing a mode jumping. Means the mode will not transfer its energy to the another mode, and this method is known as the strapping. So the resonant cavity frequency are close to each other. There is always possibility that the mode jumping and purity of signal will not be there. For providing this alternate anode cavity, for avoiding this mode jumping, alternate mode cavities are connected by metal straps so that they are in phase. Clear? And this method of stopping and preventing mode jumping is known as the strapping, and the magnetron has to operate in the pi mode. Clear? What are the typical characteristics of magnetron oscillator? Frequency range is 0.5 to 75 gigahertz. Power output frequency when it is in the range of 1 gigahertz, power output is 10 kilowatt, and frequency range is 10 gigahertz. It is power is 100 kilowatt, and efficiency, maximum efficiency can be obtained, that is 70% from the magnetron, and anode current we usually have to have a 10 to 100 ampere. Applications: this magnetron can be used in industrial heating, transmitter, microwave oven at a frequency of 2.45 gigahertz. Efficiency of this microwave oven can be achieved to the 64%, and this magnetron can also be used in radar. Clear? For providing a microwave power in the space to detect the intruder. The book I have referred for preparing these slides is Micro Devices and Circuits, and another book is that is by the Springer. Thank you.